So as Made was saying, I'm also a technical support consultant. I'm Blanca. We are going to introduce you to the Homer3 package. As the same as my colleague Aisling, we are going to focus on the mechanics of the toolbox more than the analysis itself, because that's going to be covered by Dr. Marian Usual next Thursday. So what we are going to see today will be the introductory part to help you download and add to the MATLAB path the package, so you can get started with Homer3. We are going to see what file formats does it use, and an overview of all the GUIs that form the Homer3 analysis package. But first of all, so what is Homer3? For those of you who are not familiar neither with Homer2, Homer3 is a MATLAB application used for analyzing fNIRS data to obtain estimates and maps of brain activation. It is a continuation of the work on the well-established Homer2 software, which itself evolved since the early 1990s. First as the photomigration imaging toolbox, then Homer2, and just late last year, Homer3 was introduced. So it is under continuous development. It's free. It's available online. You will see here the link to its page. And it's characterized because it has a simple object-oriented graphical interface. But if you already knew Homer2, you might be wondering which are the advantages or the differences between Homer2 and 3. And while its purpose, functionality, and graphical user interface are similar, there are several important advancements or features. So first of all, Homer3 has explicit and more sophisticated support for group and subject level analysis, while Homer2 is limited to fixed functions built into core Homer2 code. Homer3, on the other hand, has flexible and configurable support using the same mechanism as the configurable run level analysis. So each processing level, grouped and subject, run with its own processing stream to which the user can add their own algorithms. We are going to see that later. Also, adding functions to the processing stream does not require code changes to the core Homer3 code as it does in Homer2. All that's required to integrate a user function into one of the 3 processing streams is to add the file containing it to the Homer3 folder, the user functions, and add a help section in the file that can be interpreted correctly by the Homer3 process stream class parser. Then one of the huge changes is its ability to read and write in the fNIRS file format. So this is a universal file format for storing and sharing NIRS data independently of any specific application or file format such as MATLAB. Homer2 uses the MATLAB file format to store NIRS data, the .NIRS file. And Homer3 provides the fNIRS class object, which reads and writes this .snirf file. Also, we have the ability to subdivide data from one acquisition file by channels into independent data blocks and then independently process them. So the href averages from different data blocks can then be viewed by clicking on the corresponding probe channels. Homer3 does not change the original files that it uses for its analysis and clearly separates data into the acquired from original data files and derived, so any processed data. All processed data is stored in a separate group results.mat file, same as in Homer2. But so this is a planned feature for Homer3. In the future, it will add the ability to export the processed data into the fNIRS and other file formats as well. It also has a clearer, simpler, most of all simpler GUI interface. Again, even though much of the graphics are based on Homer2, it is cleaner and simpler. There are fewer controls, and the controls that are there are grouped into panels by function. So as said, Homer3 uses a simple and understandable object-oriented software design, which allows it to be more easily modified, extended, and maintained. And to get you started with it, simply let's download it. Go to the Homer3 homepage in this link we can see at the bottom side of the slide, and click the green clone or download button on the right. Then click download zip right below the green button. Once you have downloaded the zip file, unzip it. There is a standalone version available to use it if you don't have MATLAB, but we are going to focus on the MATLAB-based version since this is what we always work on. So to run it, if we have MATLAB, open MATLAB and go to the setpath tool. There you may press add with subfolders, the button, and select the Homer3 folder that you have just unzipped. That will set the path also for Homer, also for all the sessions in the future. And we should be ready to start Homer3 at this point. But first of all, let's think what kind of data do we need to load it. So as mentioned, Homer3 uses already the .snirf file, and we at NIRx, we are working on getting all our acquisition software to export directly in this data, in this data format, but this is not an available function yet. But fortunately, Homer3 already takes this into account. So as long as we have a .NIRs file in our data format, in our data folder, sorry, it will load it, and it contains a parser that will be available to convert the .NIRs to the .snirf file. So all you have to do is check that you have the .NIRs files on your data folder. If you don't have it, we will link you a support post from our help center here on this slide, so you can see how to create one from your NIRx data. So we could load this data folder directly in Homer3, but since I'm going to review what is the .NIRs file and the .snirf file, I'm going to open it first of all here in MATLAB. So let's take a look into the .NIRs structure. If we load a subject file, as seen in the screenshot, we see it's a MATLAB-based format, so it might be opened with this load function, just defining the math extension. And what we see, it's 5 variables. So we have the ST, this is a structure variable containing the source and detector geometry, the aux, the aux variable, and auxiliary signal of the same dimensions as t, so as the time point. We have d. We will see this later a bit deeper. This variable, the d variable, is the row intensity time course. It's a 2D array where each element in row y and column j contains the row intensity at time point y in channel j. Then we have variable s. This variable specifies the time points and the condition of the stimulus onsets. So we have a stimuli array, and t, so the data time points array. In addition to these parameters, additional parameters can appear in the NIRs file as a result of processing the dataset in Homer3. And if we go take a look deeper to the ST variable, we've said that this is a structure variable containing the source and detector geometry. But now we see we can just simply write ST on the command window in MATLAB, and we'll see that it has just 7 fields. So we have lambda. This would be the wavelengths used for the data acquisition. Then the sources positions and detectors positions, the number of sources and detectors. Then the miss list. This is a list of the source and detector pairs, so meaning a list of your channels. And finally, a spatial unit. And we're going to see exactly what this miss list is, because this is going to give us a lot of information on how our data and the matrices containing our data are organized. So if you click on ST and miss list on the MATLAB workspace, you will see all the channels displayed. These are organized by 4 columns, being the first of all the source position. This is the index of the source from the SD source position list. The second column is the index of the detectors. The third column is unused, so we're not going to see it. And the fourth column is the index of the wavelength from the SD lambda. So we have, in my case, I'm using a data from a montage with 16 sources and 16 detectors. So I have a total of 48 channels. So what I'm seeing on my matrix, in my matrix, is from rows from 1 to 48, all my channels corresponding to the first wavelength, and from 49 to 96, all the channels, the same channels corresponding to the second wavelength. So you see in this example, that channel 13 is formed by source 5, detector 3, and we see at row 13, there's this channel for wavelength, the first wavelength. But if we go to the row 61, we'll see the same channel for the second wavelength. And this leads us to the variable, so the raw data. This variable is the raw intensity time course. As we were seeing, it's organized the same way as the MIS list. So on the first column, all the columns are the channels. The first column corresponds to channel 1 for wavelength 1, and column 2 for channel 2 at wavelength 1, and so successively until column 48 will be the last channel for the first wavelength. So if we want to see the first channel for the second wavelength, we go to column 49. And just taking an overview of the fNIRS structure, we've just said it's the universal file format for storing and sharing NIRS data independently of any specific application or file format, such as MATLAB. You might find the specifications on GitHub on the link that's it's on the slide. And the latest version was released late last year. We need a viewer, a separate viewer that's also linked on the slide to open it, so to take a view, same as we were doing in the .NIRS file. But then we can use the H5 tools from MATLAB to work on. So if we want to display a specific parameter, or if we want to override something else. So just for you to take a look on how does it look like, we can see the same information as we were seeing in the .NIRS file. So here we see the sources and detectors positions, and here we can see something similar to the variable from the .NIRS file. So a matrix with all the raw data stored the same way. So with in my case, with 96 columns corresponding to 48 channels for 2 wavelengths. But what we are going to see exactly in this presentation is an overview of the GUIs of Homer3. So Homer3 uses this simple and understandable object-oriented software design that, briefly consists of 5 independent GUIs. The main GUI is not named that yet, but it's the Homer3 GUI itself. Then the Steam Edit GUI, the plot prof GUI, the process stream options GUI, and the process stream edit GUI. These last 2 GUIs, we are not going to deeply look at them, like seeing all the functions and the parameters that we could enter, because that, as already said, that will be covered on the webinar by Dr. Bushel next week. And typically these 4 GUIs will be started from the main GUI. This is the example we are going to take today, but any of them can be run separately from MATLAB command window if you need to just to look or to edit something specific. So let's start with loading the data to Homer3 and starting the interface. Because we were saying once we have set the path for Homer3, we can just write Homer3 on the command window in MATLAB. And since in my dataset I don't have already I don't have a .snirf file yet. It's asking me, Homer3 is detecting that I have a NIRs file and is asking permission for convert it for me. So if I just press yes, it will automatically convert it. So I will only need to worry about this step number 4, is to load a process options file. This is a list of all the functions I've used to analyze, to process my data. But if it's the first time, and of course I don't have any previous process options file, I can just press cancel, and Homer3 will load default config file. And we can move on to overview the main GUI. So this main GUI is called Homer3. It contains the prof geometry window, the data window, and the list of SNIRF files comprising the Homer3 dataset. The file window displays the list of files in the group dataset of the current session. The data window displays the data for the channels selected in the prof window, just at the right, for the file selected in the file window. The specific data displayed in the data window is determined by the selections in the plot panel, as you see below. But generally speaking, it can be either raw data or optical density for selected wavelength, or HRF, also hemoglobin concentration, either oxy, deoxy, or total hemoglobin, for a run, so for a session, for a subject, or for a whole group. Everything, so all the data types selected, you can choose which wavelength or concentration to be displayed. It is possible to select more than one wavelength or channel to display just by selecting the second choice with the right mouse button. The prof window displays the prof geometry. It distinguishes between sources and detectors by color rather than by letters versus numbers, as been done in Homer2. So here, red will be sources and blue for detectors. We can play a bit with the visualization because typically time courses for several channels are displayed simultaneously in the data window, since one optot usually has more than one channel associated with it. This is what you see on the screenshot. So I just pressed the second source, so optot source 2, and I'm seeing all the channels associated with this optot. So it is often useful to display only one time course at a time, especially if the time courses are close together or they obscure each other. And this can be done by undisplaying the channels that we don't want to see. The undisplay channels data, just left click the mouse over channels in the probe window. And this will undisplay the data associated with that channel, but it's only for visualization. We are not removing anything. We have also the plot window. We can use the plot window panel to zoom in and pan the magnified data by dragging the mouse over the data in the data window you want to magnify. To pan the zoomed data, click on the left or right arrow buttons in the panel. You can zoom out by right-clicking the data window. To reset the data displayed to the original time course, just click on the reset view button in the panel. And even though there is no specifically called data analysis window, we could say these square marked areas, we could consider them as the data analysis windows. So we have the edit options. Here is where we will access the process stream options GUI. And we will be able to edit all the parameters that we have to manually enter into our functions. Then we have this checkbox called apply to all. It copies the settings to all the subjects. This is what in Homer2 was called copy options. And then after editing these options for our functions, we would press calculate. So it will analyze the data for session, subject, or groups, depending on what we have selected on this panel more on the left, so the processing level. Here we can select if we want to apply or functions or our processing stream at run level, so session level, subject level, or group level. So the last panel we can see on the main GUI is how to manually show or exclude data. So excluding data manually means marking the time points where data is deemed to be invalid. While this by itself will not shorten the time course in the calculation of optical density or concentration, any stim marks contained within the marked time points will not be included in the HRF calculation. So data can be determined to be invalid if the signal changes are due to a factor other than hemodynamic response to an activity or physiology, such as motion of the subject. The first three buttons you see, so show, excluded, manual, auto, or by channel, refer to the processing functions we choose. So if we choose any kind of pre-processing to detect and correct motion artifacts, of course, these time segments will not be taken into account when you compute your concentration values. But if we still want to visualize them because we still want to see raw data or for any reason, we can just press and unpress these checkbox. While the last point refers to exclude time. So this can be done just by visually examining the raw signal in the data window. So here we have an example. This is a whole other data set because it had bad quality, so you can easily see the spikes. And to remove them, to manually remove them, you would first click the exclude time radio button, then drag the cursor in the data window across the time points that contain your unwanted data, as you see on the figure on the left. You should see a purple patch like the one shown, and any stimulus marks within this temporal range will become dashed to indicate that this stimulus mark has been toggled off, and it will be then not included in the HRF calculation. And even though we have already seen, I might have skipped one slide. Yeah, we have seen all the panels related to the main GUI, but there are still a couple of functionalities I would like to show because I think they are really useful. So the first of all is this show HRF standard error. So we might just go to the view menu and press view HRF standard error. So it will show up as error bars on our display window, as you see on the figure below. And the second is the file minimum, where we have access to different file options. The first is to change group, so to load another data set in an existing Homer3 session. In order to, the subsequent processing will be done on this data set and will have no impact on the previous data set. Then we have the option to export HRF or mean results after the analysis, so they will be saved as a text file in the current folder. And finally, the reset options. So the data that has been processed in Homer3 is saved automatically to disk. So run data is saved in the corresponding fNIRS file, while group processing results are saved in the MATLAB file, so in the group results.mat file. To go back to the state before any processing was done to the data, we can use the option reset current processed element for the currently selected fNIRS file, or group folder for the whole dataset. So the fNIRS file selected for reset will be returned to their original state. And if group folder is selected, then the group results.mat will be deleted, in addition to all the fNIRS files being reset. So we can move on to the second GUI we wanted to show. This is a very useful tool. We're going to spend a lot of time just modifying and editing our stimuli. This stim GUI allows the user to create, delete, and modify the stimulus marks used to determine which time points are used to calculate the HRF. To start the STEAM GUI, just select the Edit Stimulus option from the Tools menu of the main GUI. And besides displaying the stimulus marks, the STEAM window also displays any specified auxiliary signal as a black line. We don't see that here, but this is what it will do. Briefly looking at the table, here we see an unfolding menu with all my stimuli. In my case, I have only 2. I could rename these 2 stimuli to have a more user-friendly name, just clicking at the Rename Conditions button. And I could edit their characteristics, just modifying the table. So I have just the onsets, and I have the durations. If I want to add any stimulus marks, I can do that in different ways. So one is just by mouse clicking in an area of the STEAM window that has no stimulus mark, and I will be asked if I want to add a new stimulus part of the condition 1, condition 2, or any new condition. I can also delete or modify any existing stimuli just by selecting, so dragging the mouse cursor over any existing stimulus marks in the STEAM window. They will turn black, and I will be also asked if I want to assign them into an existing condition, to a new one, or permanently delete them. And another way to do the same thing is to enter any specific time points, if we know them, in the edit box of the Add Edit Steams. So we can also add them as a new condition or to existing ones. Then we can move to the third GUI. We have also this plot proof GUI. This allows the user to view the HRF in proc space after data has been processed. So we cannot see raw data here, but we can see, for example, this is the result of doing a block averaging of all our channels. So it has a controls panel at the bottom of the GUI that allows the user to scale the data, to view time markers starting with stimulus onset, view amplitude by setting the size of the time markers and viewing them relative to the data. View print channel data, which is ordinarily hidden. You can see under the applicate plot, you can see the show hidden MIRs, so measurements list. So we can see all the channels, even those we have discarded. And what we did in this screenshot is to duplicate the current plot proof GUI, so we can have the 2 figures and compare. So zoom in and out and compare different areas visually. And to finalize this presentation, as said, we are not going to get really into what does each function, because this will be covered next week. But we will see like an overview of how to set this processing stream. So if you are familiar with the processing stream functions and have a specific data processing needs that vary from the basic default configuration, a custom processing stream can be built from the complete list of functions listed in the process stream GUI. So what you see on the slide is the default processing stream that comes with Homer3. This is just a conversion from intensity to optical density, a bandpass filter, a conversion from optical density to immodeling concentrations, and a block averaging. So a very basic processing stream. What you would need to note is that a function can have multiple versions. So this is why we see here on the registry functions panel, we have the name of the function and then its usage options. So you will select in the usage options column what form of your function you want to add, pressing the add button to your current processing stream. So the order can be changed by selecting a function in the current processing stream window, so the right panel, and press the up or down button in order to move the function one space up or down in the processing stream list. When you have the desired configuration, you would click the Save button to save this stream to a config file. So meaning you could press, you see the right window, you could save this processing stream only for our current session. So to keep trying if you want to do one pre-processing step or another, for example, or you can directly press a config file and you will save this whole processing stream independently from Homer3 in order to use it in future sessions. And a very handy tool is that you can familiarize yourself with the available functions just by browsing the list in the registry functions window on the upper left section and read the function description in the help window, so just below the window. One thing that differs from Homer2 is that you can set different streams for the run at session, subject, or group level. You may see here 3 tabs that will allow us to create different streams and use them depending if we perform the analysis at subject, session, or group level. These tabs are just above the registry functions column. So the right order to start with our processing stream would be just opening this GUI and then going to the processing options GUI to set the parameters that define every function that we have on the processing stream. So this leads us to the processing stream options GUI. It displays the configurable collection of functions or processing stream that processes the raw signal to calculate the evoked hemodynamic responses to the presented stimuli. These functions that we have selected in the processing stream edit GUI, in this case, 4 functions. They are showed, and we will need to enter the parameters that determine in this case, the low pass and high pass levels of the bandpass filter, the BPF to enter in the modified Beer-Lambert law, and the time points that determine the blocks of our block average function. The exact calculation depends on the particular set of functions in the processing stream and the parameter settings associated with this with those functions. These with several examples and with more complicated data will be covered on the webinar next week. So this part of introduction to Homer3 is finished. So if you have any questions about the interface, we could address them.
Hello, hi Blanca. Thank you very much for the presentation. We still have Ted here also to answer some of the questions. So one of the things before we start the Q&A, one of the things that Ted was telling me. Hey, and we have a little one there also. So, so one of the things that Ted wanted me, you all to know is that the tortoise Mercurium also works for the Homer3, right, Ted? Mm-hmm. And also, would you like to talk a little bit about the new format, the fNIRS format?
Sure. So the SNRF format was something that kind of arose maybe 4 years ago at our NIRs conference, that we decided that given all the different formats from all the different companies, we wanted to have a common format so we could start writing tools. And unfortunately, it took us almost 4 years to come up with, decide on what that is. And we solicited a bunch of feedback from people that developed code and stuff like that in the society. So we have just finalized that within the last months. I guess that's one thing that COVID did, was it forced us to actually get on Zoom and talk to each other and finalize that format. And so actually we're planning on sort of announcing that and describing it a little bit at the conference coming up in October, hopefully in Boston. I don't know if I want it, but my toolbox is able to actually read and write to the SNIRF format, just like the Homer3. My toolbox also includes converters. So if you have .NIRs, you have NIRx or Hitachi or whatever, you can read it into, right now you can read it into my toolbox and then save it back to SNIRF format. So in that sense, you can then import it to Homer3 if you wanted to go that route. But we're trying to work where the data formats will work both between Homer3 and my toolbox then, based on SNIRF.
Thank you very much, Ted. Before we move on, we have a very important question that we need to ask. It came now, it's like, how Ted's baby is so cute. So we definitely need this one, so I'll look at her. He doesn't care. She's like, what's happening? Okay, just to relax a little bit, all in this situation. So let's go to the answer, to the question. Sorry. So the first questions that we have, which I think might be interesting to have, it's one of the attendees would like to know if they should now delete the Homer2, or if they can still go together in the MATLAB path. I mean, can it still use both?
I'm still using both. I haven't deleted anything, and I think they are, of course, Homer3 is going to replace eventually Homer2, the latest version. But for now, this was released like 3 months ago. I would keep them both and see how they work.
Thank you, Blanca. Another question also about your presentations, that one of the attendees missed what's in the column 3 of the SD MIS list.
This, according to Homer2 documentation as well, is an unused column, and it's all formed by values of 1. So it doesn't contain any important information for our prof montage here.
Okay.
It's actually frequency, and it's a throwback to frequency domain NIRs. Because the Homer2 software is able to actually handle frequency domain, like the ISS system. But for the NIRx, it's all CW, so that value will just be 1. But some of the other systems, we actually use that. So.
Oh, that's really good to know. Thank you, Ted. Another question also about the structure. It's about if you could clarify when you say to exclude data tools, that if this is excluding the data or it's actually just excluding the stimuli from consideration.
Do you mean this part, perhaps?
Yes.
Yes, so this, as I said, it's only for the 3 first buttons, so the excluded manual, auto, and by channel. They are already excluded. The time series that these buttons refer to are already excluded from your data set for hemoglobin calculation, because these are determined on the functions in your processing stream, not manually. So what you determine manually, it's when you want to exclude time. So on the next slide. But yes, so you're not deleting any time, any part of your data. You're just not taking it into consideration for your hemoglobin computation.
So when you remove a stim event, you click on it, and that line, the vertical line becomes dotted. What that does is that excludes it from the block averaging or the GLM, that it basically just treats it as rest period, or there's no stim there. But that data, if you just click on and make that stim event dotted, take out the stim event, the data still ends up counting as noise. So the other way to do it, so it takes it out as from the averaging, but still counts it as rest period or whatever when it computes noise. When you select a segment of time and actually remove it so it becomes pink like that, where it's actually chunking out an entire time series, then it's actually removing it from the entire analysis. So it's not, when it runs the block average of the deconvolution, it actually just takes that data out. So you have less number of samples than you did before, but it doesn't count towards either the estimate of the response or the estimate of the noise. So depending on whether or not it's an accidental mark that this shouldn't be a STIM event versus data that you actually want to remove, you can use those two features that way.
Okay. Milene, if you'd like to ask the next question.
Yes, I will take over. So I have here a question for Blanca. In the probe layout GUI, why does it show all the stimuli if the response it is showing is the averaged block?
So here you see that the average block for all the channels.
Okay. Okay. We also have another question here for Blanca. Is there hyperscanning functionality within Homer3? Do you know that?
That I'm not sure. If that knows. If not, we can cover that for next week webinar.
I'm pretty sure it's not there yet. There might be resting state connectivity, but I don't know if Homer actually, where you have one file from subject one file from subject two to do the hyperscanning between it. I don't think Homer2 supports that yet, or Homer3. One advantage of Homer3 over, say, my toolbox is Homer3 has a lot more people contributing code. And so it's, if you wanted to write your own hyperscanning module for Homer3, you could and introduce that. My toolbox actually has hyperscanning in it already, but.
Okay. Just coming back on that question, Blanca, about the average. So they're actually asking what's exactly these black lines there in this GUI.
Mm-hmm.
Yeah. If you
yes,
could just
sorry.
explain that.
I misunderstood the question. So if you see, there's a time mark panel on the main blob roads GUI. You can set where you want to set these time marks. But so if I place them on 5 seconds, just to show them. But what you're seeing on the like the whole time series you're seeing for each channel, it refers to the whole block of the block averaging. So my block was 20, I don't remember, 22 seconds. So I'm seeing the whole 22 seconds, but I just set a time mark at each 5 seconds.
Thank you. Another question we have is there any .exe, let's say for Homer2, for those who don't have all the required MATLAB Toolbox licenses?
There is a standalone version for Homer3 as well that doesn't require MATLAB.
Perfect. Thank you very much. We are having a lot of questions again. They're pouring very quickly.
Yes.
People are asking when the webinar will be available on the NIRx website. I would say hopefully within a week. The fact that we have 2 more next week, I would say between 1 to 2 weeks, they will be on our website. So you will be able to watch them again. And for sure, like I mentioned, all the questions, we will review them and answer them as well. I have a question here. How does the pre-whitening operates when you chunk a segment of the data? Does the algorithm considers that the correlation is broken between different segments?
I will let Ted answer that if he's able to.
So, oh, scared her. She was power napping there. So I can't speak on the Homer3 how they do pre-whitening. It does have some of the same algorithms that we gave code to that they put into the Homer3 software. In my analysis toolbox, we don't allow you to chunk out data like that. So it's not, we just deal with the entire time course. That would certainly be a problem of whether or not you compute autoregression for each chunk separately or kind of pool it. I don't know how it's done with Homer3. My best guess would be that it actually includes the chunk of time that you've removed even when it computes the whitening, but then when it goes and solves the GLM, it kind of takes it out. So it's not the best approach, but it avoids that issue of discontinuities. I'll have to look, I can look at that and provide more detail because I'm not entirely sure how it's done in Homer3.
No, that's great, Ted. We can actually, I mean, we will send these questions for you later, and we will also send to Miriam, so it's not a problem. I mean, we will also ask her, and it's fine. Thank you very much for helping us with this. I think we have time for one more question, right, Milan?
Yes. Ted, you already started basically answering this question, but just to give you, let's say, more time to really go through, we have a question that says, what are the rationals, so main pros and cons when choosing between these two toolboxes, Homer3 and Brain Analyzer? And there's a lot of thank you, by the way, for the presentation across the board. So
yeah, you're welcome. So originally, when I wrote the Brain Analyzer, the toolbox stuff, this is going back 14, 15 years ago, I had just come to University of Pittsburgh and I started working a lot with end users. And Caroline, can you turn that down, please? And really what the realization was one of the things that was lacking from Homer2 at the time was the ability to do things like mixed effects models, group analysis, just proper statistical models that weren't in the Homer2 package. And kind of the realization was that actually it wasn't that even that they weren't in the package, it was the way that the infrastructure was set up made it really, really hard to do some of those things. And so in writing the toolbox, we kind of started at the other end of, now that I have these colleagues that want a mixed effects GLM model treating age as a covariate of no interest, yada, yada, you know, how do you actually propagate your NIRs through to be able to answer that question? And we kind of then worked backwards, getting the stats right and then working backwards to, you know, the pre-processing steps and so on. So my toolbox is very heavy in the statistics, particularly at the group level. And it's a lot lighter in the pre-processing, the kinds of the principal component analysis, a lot of the filtering that is kind of the basis for Homer2 and Homer3. So over the years, we've started to put in a lot more of that pre-processing. And so now, you know, my toolbox has a lot of the options that Homer has in terms of the pre-processing. In fact, there's actually a module called Run Homer2 that allows you to actually take any of the code that's in Homer2, like your favorite motion correction algorithm from Rob Cooper or something, and put it into my toolbox within the same framework. So we can actually call any of the Homer2 functionality and then the Homer3 functionality when I get around to implementing that. Homer2 or Homer3, on the other hand, it has a lot more user contributions. So over the years, we've had a lot of people developing code. You know, you come up with a new motion correction algorithm, then you publish it. It's been fairly custom to write that as a Homer2 module and kind of get that in there. So with Homer2, there's a lot more options, particularly on the pre-processing end. It's a curse and a blessing. Because the question we always get with with the Homer software is, which of these 10 versions of motion correction should I use? And the answer is it kind of depends on what your data looks like, and they're all kind of designed for slightly different assumptions and types of data. So there's a lot more options with Homer2. I will say with the Homer3, there's more of an emphasis on the statistics, and so it's now the difference between my toolbox and the Homer3 toolbox is starting to become a little less distinct. Mine was originally stats and theirs was pre-processing, and then I built pre-processing and they built stats, and so they're now kind of merging together a little bit. I don't know if that was a satisfying answer, but yeah.
Absolutely.
Yeah, thank you very much. So, like we said before, we will follow up with the other answers. Everyone is very happy with the webinar. Like Milene already said, a lot of thank you, Ted, thank you, Blanca, thank you, Ashley. Also, if you want to come back now, also. Thank you for attending also our webinar. We hope that you enjoyed. We enjoyed a lot for sure. Thank you, Patrick, also for coming back. We will make it all this content available, and probably after the webinars, the webinar series. And we hope to see you next Thursday for Dr. Miriam's webinar, and next Fridays for Dr. Herbert's again webinar. So thank you very much.